Hello, my name is Marco Sauder from Krantz in Germany, and today I want to give you some information about our bulk carbon filtration system. When we speak about carbon filtration systems, we need to define also the selection criteria for the carbon filter systems. One limiting factor is the phase velocity. So the phase velocity needs to be in a range from 0.1 to 0.5 meters per second, so that we are below the disengagement point of the carbon. Because if we are getting too high with the phase velocity, you can see here, according to the standard, by 0.8 meters per second, the carbon will start to vibrate and it will collapse over the time. So you need to avoid this point, and therefore the optimum phase velocity is between 0.1 and 0.5 meters per second. The second criteria for the selection and design of a filter housing and a bulk carbon filter housing is the volume flow, and of course the dwell time, which is required to absorb the hazardous substances with the carbon. Once this is done, you can then create the design of the filter housing, and you can calculate the amount of carbon required to achieve first the phase velocity, to have the volume flow and the right dwell time. If you have low risk gaseous pollutions, then you could work with a filter cassette technology. This is a long time used procedure, so you have a kind of a filter cassette, which you can see here on the left hand side. So a filter element which houses carbon inside. The size is standard 610 by 610 filter element size. You have a minimum dwell time of 0.1 second, which could be up to 0.5 seconds, depending on the volume flow you use for this kind of filter cassette. But you can also see, due to the amount of carbon and due to the structure of the filter element, you have a weight of 76 kilograms per filter element. And this means in the end that a back-in, back-out technology, changing the filter element via back-in, back-out, is very difficult, and therefore we only recommend using this kind of system if you have low-risk gaseous pollutants. If you have to absorb high-risk gaseous pollutants, then we recommend using a bulk carbon filtration system. The difference between the filter cassette and the bulk carbon filtration system, you can see here. You have an inlet chamber, you have one carbon bed, and you have an outlet chamber. And here you can see an arrangement with a pre-HEPA filter stage, so you can avoid loading particles onto the carbon. You have the carbon bed itself, and you have a downstream HEPA filter to avoid that particles from the carbon will go into the ductwork. You also see here at this point we have a drainage point. Here we can easily drain the spent carbon into barrels without having the need to change a filter cassette or a filter element, so only the carbon itself will be the waste you are producing over the time. And each housing is also equipped with a sampling ports. With these sampling ports you are able to extract carbon from the carbon bed at different positions in the carbon bed, by easily draining carbon into test bottles, and with these test bottles you can get to a laboratory to see the loading of the carbon. Also, if you have more filter beds required, or you have higher volume flows or longer dwell times, it is also possible to have a multiple arrangement. Like you can see here, we have two inlet chambers, two carbon beds and one air outlet chamber, so the air is coming into the housing, split it over two beds and one common duct going back into the ductwork. And on the picture you can see one of these pictures. So you have here the two carbon beds in parallel, and both of the carbon beds will have their drainage point for the carbon. So this means it is an easy handling of the safe change technology, because you will drain the carbon into a barrel where you have also the safe change bag connected, and you can easily change this contamination free. It is a compact design. It is simple and efficient to clean and refill the filter, the carbon into the filter housing, and you have a high protection of the environment and the operational staff during operation, during changing of the carbon, and during filling and draining it. If you want to have a better or a more efficient way to have the carbon filtrations designed, then we also have the possibility to have our CFH high-tech housings. So if you see a typical load curve of a carbon bed, you see about half of the carbon is spent, the other half of the carbon is usually not spent, but you are at a point where you need to change the carbon because you cannot use it, because at this point you would have already breakthroughs to the carbon. So the idea is to split the carbon bed into two halves, so that the air is first getting to the first half of the filter bed, redirected, and then to the second half of the filter bed. In this case, the carbon on the lower side or on the downside of the filter housing will be loaded first. And once this carbon is spent, with a barrier slide you can shut off this area and you can just drain half of the bed, and then you open the barrier slide, the top carbon will fall down into the lower bed, and then you only refill half of the carbon. So this would be a maximum saving of carbon used over the lifetime, and these systems are designed if you have to change frequently the carbon. And here you can see a typical design. So you see here both beds, in the middle are the barrier slides, and then you can just drain always the lower bed, and the top bed will fall down. And you see here we achieve dwell times of 0.8 seconds, and we have here an airflow in this configuration of 100,000 cubic meters per hour. Here we have another installation. You see also the Slaria bites here, barrier slide in the middle. We have here 2,400 cubic meters per hour and a dwell time of 1.5 seconds, because this was used for chemical decommissioning, chemical weapon decommissioning, where you have high risk pollutants, gaseous pollutants, which you need to absorb, and a lot of pollutants. So in this case, you can save a lot of carbon during the lifetime of the system. Yeah, I've just talked about chemical decommissioning, or chemical weapon decommissioning. So you can use carbon for remove iodines in the nuclear industry, or you can use it for chemical weapons which maybe affect the skin, which affect the lungs, the blood, nose and throat, or other substances, like you can see here. So there is a wide range of using carbon filtration systems. It always depends on the kind of gas you want to absorb, and with the information of the gas we then can select the right carbon for the system. And now we want to show you how to fill carbon into our housings in a contamination-free way. Here you can see a typical arrangement. You have the carbon filtration systems with pre-filter and second filter behind on the other side. What we need in addition is a HEPA filter to get air into the carbon filter housing. You need a re-cleanable unit to collect dust, which occurs during filling of the carbon, and you need a pneumatic filling device to get carbon into the housing. And the pneumatic filling device, so you see here the barrel with the carbon, you have an injector tube, and you have compressed air, and with the compressed air you are able to shoot carbon into the filter housing. It will work. We will show you as a next step together with my colleague. Yes, so as just seen on the slide, now the live setup of the system. We have here the carbon filtration system coming with the air inlet, pre-filtration H30 to protect the carbon itself, so that particles will be absorbed upfront and only gases get to the carbon filtration side. On the downstream side, you see the second HEPA filter, which is the H11 filter element. This is to protect the ductwork downstream if fractions get loose from the dust, from the carbon. So this dust will be collected by this filter. To fill the carbon, we have now connected different devices. Starting on the left-hand side, we have here the air inlet filter. filtered air which gets into the housing. During the filling process, we have the filling device itself. So we have filling device to operate the injector, and this is connected to the housing on the top. So from here the carbon will be shoot into the housing. We have a vibrator unit on the housing so that we can dense the carbon during filling, and we have then an extract here which is going to our Re-cleanable HEPA filter, which you can see now. And with this combination of air inlet and the Re-cleanable filter housing, we are able to maintain the loop here that during the filling of the carbon, the dust will be collected by the Re-cleanable HEPA filter and fresh air is going into the housing to avoid that we get a negative pressure inside the housing. And as a next step, we will show you now the filling itself. So therefore we will set up the equipment in the right position, and then you will see how we will shoot the carbon into the housing. So to start the filling process now, I have to switch on the Re-cleanable unit so that air is circulating through the housing. So it will be a bit more noisier now, but I hope you can still understand my explanation. So I will start the system. And as a next step, we need then to switch on the vibrator and the filling device. So this will be positioned in this area. So here we have the control system for the vibrator, which is located on the filter housing. And when I switch this on, this will just vibrate 10 seconds as the beginning. Then we have 2 minutes pause during the filling, and then 10 seconds vibrating. And during this process, which goes continuously, we will still fill the carbon. So I will switch it on now, then we have 10 seconds of high noise, and then we will show you the filling procedure. So this were the 10 seconds. Now we will activate the carbon filling. So we activate the compressed air, and then you can see how the carbon is sucked into the nozzle and is shooted then into the filter housing. So, and like I said, we have now 2 minutes, and then automatically the vibrator will start with another 10 seconds vibrating. So this will be done to compact the carbon also during the filling, so that we have after a certain level a vibration to settle down the carbon, and we will continuously filling now drum per drum the filter housing. And the carbon is now going all the way up into the housing, into this position on top. And there you can see also the vibrator. And you see the filling or the emptying of the barrel is continuously. And as the Re-cleanable unit is running, you will have still extracting the dust coming from the carbon, or possible dust from the carbon will be extracted, so that you have clean conditions in the carbon bed itself and in the housing itself. So now 10 seconds left before the vibrating starts. So I will go to the top position so that you can also see the vibrator, and you can see how So we have now filled the carbon filtration system, so barrel after barrel until the complete carbon bed is filled up to the highest point. So once the carbon bed is filled, you will feel it on the injector, so it is not possible to shoot more carbon into the housing, and this is the point where you know everything is filled. As a next step, we want to show you how to drain the carbon from the system. We leave the equipment like it is, so in reality we would remove all the connections, of course, because the carbon is now filled. You can now operate the system, but in this case we just change the camera position so that you can see the drainage. So in reality those pipes would not be there. And if you want to have over the time measurements of the carbon itself, You can then extract slopes from the carbon bed and analyze the loading of the carbon. And then you can decide, okay, I can still operate the system, or the carbon is that loaded that you need to remove the carbon. Open the ball valve for the carbon extract. And now with the hand crank, I can easily drain the carbon. So you see the carbon coming out. And with this hand crank, it is also easy to control the amount of carbon that we are getting out. So we have now drained the carbon into the barrel, and now we want to change the maintenance bag so that we are able to fill another barrel. Therefore, we need one new maintenance bag. We need one new rubber ring, and we need a clamping device to clamp the bag and a heat seal device. And now we will show you the procedure how to change the bag. First of all, we have to clamp the bag. So therefore, we press together the bag. Then we use the clamping device. So we clamp the bag now to compress it and to be able to seal then the bag in one step with the heat seal device. So we create now a channel where we can cut the bag with the hot knife. Okay. So with the hot knife, as using like a saw, we will cut through the bag without pressure, so it is only by the heat, so that we get a uniform sealing of both ends of the maintenance bag. Once we are through the complete bag, we then go again with the hot knife on both sealing surfaces to ensure that both ends are sealed in the right way. So once this is done, now we have to cool down the bag. Maybe one hint, we are using PE bags, and when using PE bags and cut them with a hot knife, the gases coming out are not hazardous. So therefore it was a safe change and without any problem for the staff doing the maintenance bag change. So now both ends are cooled down, so I can open the clamping device, and then you can see that both ends are sealed in one procedure. So you can see this one is sealed, and the same is with the other end. This is also sealed. So you have now one bag remnant on the unit, and the other maintenance bag is now filled with the carbon and could be put into the waste stream. Now to put in a new maintenance bag, we have two grooves. So the upper groove will be released now from the ring, and this ring will be reused. So we have one new maintenance bag, and we have one new rubber ring which we use later, and then we just fold down the maintenance bag over the first groove so that the upper groove is free. And now we can place the new maintenance bag. Now we just put the maintenance bag over the old maintenance bag, and we need to ensure that the old bag will not be clamped together with the new bag, because then it would not be possible to remove this bag. So now we put in the first rubber ring, push it into the groove, all around it. And it's also important to have the handle on the front side so that you are able for an easy access to the handle of the rubber ring. So now the rubber ring is placed, it is tightened, it's fixed to the collar. Now we can use the new bag as a glove
and we can remove the remaining back remnants. So now the old rubber ring is in the new bag, and we can also remove the old bag into the new bag. So in this case, we have again a new bag. We can place now also a barrel underneath it, and then we can start draining the next barrel. So as the last step, we just fix the second rubber ring. And also here it is important to have the handle in a position where you can easily have access to it. So and now you could continue to drain then the next barrel. And that's the procedure how to fill and how to drain the carbon in our carbon filtration systems. Thank you very much.